So chapter 11 is about feeding the world. The book opens up with the story of Joel Salatin. He's going to be featured in Food Inc., and he does farming differently. He considers himself to be a grass farmer. Grass is the foundation of the trophic pyramid, and he allows his cattle to graze in large areas of land, not a feedlot, and leave manure. The fly larvae come in, and he brings in what he refers to as his sanitation crew, his chickens. The chickens come in, they eat the larvae, they help spread the manure around, and allows that, to refertilize that grass so that his cows can then continue to eat. In the winter, he leaves the manure in the barn. He allows that footing to grow up higher, and it decomposes there. It produces heat to help warm his cattle. In the spring, the pigs come in, they dig it up because he's planted some corn in there, not to grow, but corn that they like to find, and they churn up that manure. What is the point of all this? The point is that there's a lot of different ways to do agriculture, and big agriculture is not the way Joel Salatin does it. He's doing small agriculture, and we're going to see some of the impacts that large agriculture has. We're going to start by looking at global undernutrition. So what are malnutrition and undernutrition on the rise? 24,000 people starve to death each day. That's 8.8 million people each year. In the 20th century, you can see from this graph that we've made tremendous gains in agricultural productivity. But if you notice, we had an increase in the millions of people that are starving. Okay, we were at our lowest point in 95 to 97. And part of that is there's been a decrease in the government assistance for agriculture development, especially in developing worlds. There's increased fuel prices and the economy has gone down. The number of people that currently lack access to adequate amounts of food is 1 billion people. And the number of people that are malnourished, according to the World Health Organization, is 3 billion. That's half of the world's population. So let's dive into those words a little bit. We have some things like food security versus food insecurity. Food security is the access to food and quality food, whereas food insecurity is the opposite. The three major food problems are undernutrition, not consuming enough calories to be healthy, which is different from malnourished, which is diets that lack the correct balance of proteins, carbohydrates, vitamins, and minerals. So you might have enough calories, but you don't have enough of the proper calories. And then we've run into the current problem of overnutrition, ingestion of too many calories and improper foods. This still puts people in risk of disease. So you might think, I don't want to be undernourished or malnourished, but you also don't want to be overnourished. It leads to type 2 diabetes, heart disease, things that we're more familiar with. Famine is a food insecurity that's so extreme that large numbers of deaths occur in a given area over a relatively short period. This can occur from crop failures, from something like a drought, to social and political causes. If we look at human food consumption, the number one component that we consume is grains. Grains like corn, rice, wheat, rye. It's 60% of the human intake. The second component is meat. It's defined as livestock, but not fish. And consumption of meat is on the rise. And we know that meat is much higher in the trophic pyramid. So we're putting transferring 10% of that energy from the grains into that meat. And then everything else is third: fruits, vegetables, fish. The reasons that we have undernutrition and malnutrition: current grain production is sufficient to feed 8 billion people. So why do we have this going on? Well, number one reason is poverty. There's political factors, there's economic factors, and we're quite honestly taking the bulk of that grain to feed livestock. The corn and the soy, the primary components of livestock. The human population is set to grow to 9 billion. So we have sort of this interesting paradox here where we could probably feed 8 billion with grain production. We only have 7 billion on the planet, and we can't feed them already. And if we're set to grow to 9 billion, we're going to have to make some changes. We're going to have to figure out how we distribute food more equitably, how we get more of that food into the hands where it needs to be, and maybe consume less of the things on higher trophic levels. If we start to transform agriculture, and energy subsidies, this idea that energy input per calorie of food produced. And so if you look at this little scale here, how much energy goes into offshore fishing versus small-scale corn and large-scale corn versus hunting and gathering, these kind of things. Small-scale food production is mostly human energy, whereas large-scale modern food production relies heavily on fossil fuels. So if you're looking at how much energy goes into making the ingredients, you have to think about things like bananas being shipped from South America and produce being shipped from California, whereas hunting and gathering was eating things local and seasonal all the time. And so that's what contributes to this huge energy that goes into making our food. The Green Revolution is made up of 5 components. I have them listed on your notes, but then we're going to go through them a little bit in detail. So this mechanization is the idea that machines take over many of the jobs that were done by hand, but it leads to large-scale production. It doesn't make sense to put a lot of money into a grain harvester if you're only going to have one field of grain. It makes sense to put large quantities of money into something that can do that if you have fields and fields and fields and acres to harvest. Irrigation, we've talked about with water problems. It's the same sort of thing. It allows crops to grow where they couldn't before, and it leads to water shortages, saltwater intrusion, water logging, salinization. So too much water impairs root growth. Salinization, where there's salts in the irrigation water, become highly concentrated because water is evaporating. But it allows us to make unprofitable land profitable. Fertilizer. So fertilizer provides limiting nutrients to plants: nitrogen, phosphorus, potassium. Organic fertilizers are composed of organic matter of plants and animals, things that are breaking down, as well as waste produced by animals. Inorganic fertilizers, which are synthetic fertilizers, are produced commercially. A lot of combustion of natural gas is used to fix that nitrogen that's in the air. And this has quite honestly been argued as what is allowed to feed the world. If we didn't have this ability to fix nitrogen artificially, we wouldn't be able to feed the population of the world that we have now. Monocropping is growing a large amount of a single species of a plant. This is a very common practice in the United States, and a lot of this has to do with this mechanization. Why are we going to buy this giant machinery to harvest wheat if we only have one row of wheat? It doesn't make sense economically. And finally, the last one here is pesticides. We'll do an overview, and then we're going to talk about them a little more in depth. But a pesticide is a substance that kills or controls organisms that people consider pests. Typical types are based on target organisms. So an insecticide kills insects, an herbicide kills herbs or weeds, a fungicide kills fungus, and a bactericide kills bacteria. And then we're going to talk a little bit more about pesticides here. So characteristics of pesticides, we have both broad spectrum and selective pesticides. So broad spectrum kills many different types of pests, whereas selective pesticides focus on a narrow range of organisms. Persistence are pesticides that remain in the environment for quite some time. They stay. Whereas non-persistent, they leave the environment quickly. Problems with pesticides, they also kill beneficial organisms. If we kill the ladybugs that are going to help prey on some of the things that we need them to get rid of the aphids, and we kill them, then they can no longer help us. Non-persistent pesticides problems is that we need to constantly apply. So we have these ones that persist for a long time, but then we also have ones that go away quite quickly, and we need to keep applying them. Bioaccumulation is caused by persistence. So whatever that substance is fat soluble, so it's attracted to the fatty tissue. And the prime example of this is DDT. It killed the insects, but then it built up in the middle level organisms without hurting them, didn't hurt the fish, didn't really do anything to the fish, but the bigger fish ate the littler fish, and the bigger fish, and the bigger fish, and then by the time it built up, the bigger fish had quite a bit of that DDT in them. The problem came when the eagles started eating those fish, and the DDT did have a negative effect on them and caused their shells of their eggs to crack. The pesticide treadmill is the first thing that Rachel Carson brought up in Silent Spring, this idea that pest populations may evolve to resistance to a pesticide over time. So, I mean, pesticides definitely have large populations. And if you have a large population, you're going to have genetic diversity. So when you apply whatever that pesticide is, some of those pests are going to live. The pests that live had the genetic diversity to be able to overcome that pesticide. Those pests are able to rebreed, and now you have an organism that's able to withstand that certain pesticide. So in order to combat this new sort of breed of organism, we either need to apply more pesticide or change our pesticide and make it more powerful. Pesticides also kill beneficial organisms. They kill predatory organisms. They kill pollinators. They kill plants sometimes that fix nitrogen. So there's some problems there. Looking at other types of agriculture, looking at genetically modified organisms, this might be a good place to pick up our next video.